Hello and welcome to the second part of our video series on the topic of structural analysis with SolidSteel parametric for SolidWorks. In the videos we show different methods to perform the structural analysis and calculations after the design has been created with SolidSteel parametric. Today we use the SDNF export to easily transfer the static system and other important parameters to third parties. Of course, SolidSteel also offers the possibility to re-import the structural analysis back as SDNF and to perform necessary corrections automatically, but that is topic for another video. The structure we have now seen from all sides is our model for this demonstration. The SDNF export is easy with SolidSteel and the file, which is tiny, can quickly be emailed. I now sent the file to Daniel at Dlubal Software and he shows us the static calculations in detail.
Hello and welcome, my name is Daniel and I work for Dlubal as HR manager, and I am also responsible for the video marketing and take care of our customers and users in the customer support. Today I'm going to show you how to import a SDNF file provided by the software SolidWorks and the plugin SolidSteel. Therefore we work with the structure analysis software RFEM 5, and there it's possible to import such SDNF file. Therefore, I go here to RFEM, I click here on File and click here on Import, and there I have different possibilities to import different files. And if I click here, SDNF format, so the steel detailing neutral file. SDNF is a format for the exchange of steel elements, especially for geometrical data like nodes, cross-sections and members. So I click OK and I choose the file I want to import. And I imported it to my structure analysis program. Because I haven't created a model before, the program wants me to create a new project or a new model. So I insert here the model name, structure, save it under the project name examples. And I want to do the classification of load cases and combinations automatically. So the load combinations will be created automatically and according to the standard Eurocode and the German National Annex. So I click on OK and the structure appears. So before we do our structure analysis, we have to check some things. So first of all, the geometry check. So as you can see, it is not correct rotated. So I select the whole structure, right click, I click on rotate, and I do the rotation with an angle of 19 degrees for the x-axis. I click OK, and now the structure is on the right side. So the next thing is delete the unnecessary nodes and lines. When we zoom in, we see here 4 nodes and 3 different lines. These are lines which aren't important for our structure analysis, therefore we can delete it. I select them and now I click on delete on my keyboard and the lines and nodes disappeared. Okay. The next thing is that every member has a member orientation. When I go here to this connection bridge of the structure, I can see that on the right side have a different member orientation. I want to change that because I want that the member orientation is always in the same direction. So I click on that member part, press the Control key and click on the other member part, right click and say reverse member orientation. Okay. Good, so this was the geometrical check. The next check is the material check. Therefore, I would recommend you going to the left side to the data navigator, open the tree of materials, and there you can see 2 different materials. So when I double click on the first one, the whole structure is selected. Double click on it, I can see that the material constants or properties are 0. So there was a mistake with the import, but this is no problem because I can edit it afterwards. So I choose here from the material library, material, and this is the material S235. So I open the material library, go to the correct steel material, and this is this one, steel S235, according to the Eurocode. I click OK, and all material properties are correct now. Okay. And now you can also see how the color was changed. The second material is this 01, and every time when in RFEM a material is colored blue here in this data navigator, it means that these information aren't available for objects. So we can delete it. So this was the material check. The next check is the cross-section check. Therefore, I go to the cross-sections and see if the cross-sections were imported correctly. And as I can see, the cross-section seems to be correct. Okay, good. Here, a tip from my side. When you import different material or cross-sections names, it can be possible that there are some mapping problems. In RFEM, we have the solution that we can map these names of the cross-sections or materials. Just go here to the file, go to import or export. In this case, I click here on import and go to the register detail settings. And here you can modify the conversion table for materials and cross-sections. Just click here on edit, insert here the name of the imported files or applications, like the SDNF file. So in this case, it would be this 10037, and choose here the correct name in our material library. This would be this one. And I save the conversion table, and for the next time I import the same material from this SDNF file, the program remembers it and I don't have to edit it afterwards. So this was the cross-section check. Now we modify the model a little bit. First of all, I want to add some single supports. Therefore, I select all, go here to a new nodal support, and I want to give them a hinged support. I click on OK, and all nodal supports were added. The next thing is the member hinges. In this case, at the connection bridge, I want to add on both ends 2 moment hinges. We have here 2 possible ways how to do that in RFEM. First way is creating the member hinge with the help of the data navigator. So go here to member hinges, click right click, new member hinge. The hinges are normally referred to the local member axis of the members. I want to create a member hinge, so I activate the rotation around the Y and Z axis. I click on OK. And now I can assign these hinges graphically to members. I click here this member and this member on both ends. I click OK, and you see here now the hinges. With the help of the different display models, I can also activate this wireframe model, and then I see the hinges a little bit better. And now I do the same on the right side, and here I use this way of adding the hinges. Right click, edit member, and every member is also referred to member hinges on both sides, so member start and member end. And here we have the member end, and here I activate the member hinge. Good. Show me the whole model, change the display model, and the next thing is that we want to summarize here these 4 different members to one member with the help of the set of member. So therefore, I select all 4 members, right click, and say create set of member. Description can be what you want, but I leave it here as continuous member 1, and I do the same for the other one. Okay, good. This set of member has different advantages. First of all, I can summarize several members as one member. It's easier to apply loads, and also for the result interpretation and furthermore of steel structures. Okay, now let's go to load cases and loads. So therefore, I create 2 new load cases. The first one will be the dead load or the self-weight. So I activate here self-weight. Self-weight is active, and I create a new load case, imposed load, and the action category is storage areas, and I click on OK. Now I want to apply the loads on the different load cases. So I start with the load case self-weight to apply on the left frame loads on the connection bridge and also on the right side. So we have here a very nice function. When you go to Tools, Generate Loads, we can apply loads from area loads on members via plane. I click on that. And here it's very important to set the correct area load direction. In this case, I choose here ZL. And the magnitude is -1 kilonewton per square meter, Y minus, because our global Z-axis is showing upwards. Now I choose the boundary nodes or the corner nodes. These are these ones. I click OK and say OK. Good. I can separate the surface load by clicking Display Separately, and now you can see how the loads are applied on the members. Okay, in order to consider one direction, one span direction, I will do now the same on the right side again. Also -1, but the corner nodes are different ones, so I click here again these corner nodes, click on OK. And now I want to remove the influence from these members who are parallel to that one. And you see, okay, only these 2 members are selected now, and only on these 2 the load will be applied. I click on OK. And now you can see here these member loads. Okay, as I said before, with the help of set of members, we can apply loads very easily. Therefore, I refer to sets of members and set up here the load parameter 0.5. I click on OK and select these 2 set of members, but in this case I forgot to give them a negative value of the load, so no problem, I will change it. Okay, good. Yeah, now I want to have the same loads for my next load case, but with different values. So I go again to the data navigator, self-weight, and with right click I want to add load cases to the second load case, so to the existing load case, to that one. I click on OK. Now we jump to the next load case, and you see the same loads here. What we do now is just changing the values. So in this case I have 4 kilonewton per square meter. Double click to 4. Here we do the same on the right side. And here the same thing again. Okay, good. So this was the applying of the loads. Let's go back to the definition of load cases and combinations. Maybe I lose here also some words. For our calculation, we have here the different actions defined, permanent and imposed. We see here also the action category again. Let's go to the combination expressions. There we only consider the ultimate limit state, so I don't consider any serviceability just for this example, yes, I want to delete them. And according to the set combination expressions, different action combinations are defined, and therefore also different load combinations, and also this result combination. Okay. Now I calculate everything, therefore I click here on Calculate All, and all load cases and load combinations and result combinations will be calculated. Okay, very good. The first result in RFEM is the deformation. So in this case we have the result combination activated. We can see here the deformation. We can also activate as the different internal forces like the bending moment, normal forces, as well as shear forces, and of course support reactions, and also the result combination with maximum and minimum values or both values. Okay, good. Of course I can add them to my printout report, or I can export the values via Excel. This is possible for the documentation. Good. Now we'll do a very easy design of the steel members. So if you want to do a design for steel structures, we have our add-on module RFSteel EC3. This allows you the design of steel members according to the Eurocode 3 and performs all characteristic designs of the ultimate limit state, as well as stability and deformation analysis. Good. Double click on that. I open this add-on module and I want to design all members and also these two set of members. So therefore I create new cases. First of all, I rename the first case. This will be the case with the members. I click OK. And there I choose all members without these short ones here. And the same also for the right side. Maybe the wireframe model is a little bit better to pick. I click on OK. Now I choose the result combination for the selected results for the design, and the national annex is the German one. I go through here these different windows, materials. There I can see the used material for the design. In this case we have only this one material, a different cross-section, intermediate lateral restraints and effective lengths for the stability analysis. And now I run the calculation. And as I can see, the ultimate limit state, very good ratio. Yeah, sounds good. And when I see here the design by cross-section, I see also here the different proofs. Now I do the same with the set of member. So I create a new case, set of members. I click on OK. There I select the two member sets. These are these ones. Again here the result combination for my design. I go here these steps through, materials, cross-sections. I think this is clear now, also this intermediate lateral restraints. And now I have the possibility to add some local support conditions like lateral support, rotational restraint, and so on. I can show me them here on that picture. And this is important for the stability analysis, because for set of members we generally use the general method for the stability analysis. And for that simple example, and on the safe side, I assume that the buckling length is the whole length of this girder. So I neglect here maybe the stiffening braces, and I run the calculation, and the design ratio is succeeded with a ratio of 0.37. Good. After the calculation and the design of this steel structure, you can create a printout report. By clicking On the left, in the project navigator, I click here on New Printout Report. I can give the printout report a new description and edit the selection of the printout report. There I have the possibility to check several options, and in this case I only want the results of my result combination, so I deselect the results of the load cases, and then the printout report will be created automatically. Okay, on the left side you see different chapters divided in different categories. So by clicking on one of this chapter, I jump to this chapter and I see here these information. Now I can give you another tip. This is the creation of a mass print for the printout report. So we can create very easily similar images of different results or different loads and so on. I go here to the print graphic, click here on mass print and choose the settings, and here I want to generate graphic in an isometric view, and say also for each load case I want to create also a view. So I choose here my load cases, my two, and I want also to create different images and graphics of my results without loads and only for the result combination, and also this defined view. Okay, now I choose the correct results. So in this case, I want to have some internal forces like the normal forces, shear forces, and maybe also the deformation. Now you can see here, number of graphics is depending on the chosen results here on the right side. And I can see then in the printout report the generated graphics. And these eye icons symbolize me that there are images. This was a very simple example on how to import an SDNF file, do some modifications, add some information and run the calculation, and also do a simple design. If you want to find more information about our programs, RFEM or RSTEP by Dlubal Software, go to our website, dlubal.com. Thank you very much. I hope you could learn something, and I wish you also a lot of fun when trying these things by yourself. See you and bye-bye.